Hello everyone. In this small presentation, I would like to give a concise talk about modularity and abstraction. I think these concepts are very important in computer science, engineering, and also in management. Uh, we will talk about what is modularity and why we need it. Also, we'll give some examples in software engineering, management, and also in computer networks. So, what is modularity? Modularity means you take a big problem and break it into small manageable pieces so that we can change and manage each module without affecting the other modules. Here we have an example. If you have, for example, a very modular mobile phone, we can take this mobile phone and we divide it into small modules. Each module has specific job. For example, we have a Wi-Fi for connection and battery, for power, storage, antenna. So you take the whole big problem, which is designing a mobile phone, and you divide it into small manageable pieces. Modularity in management, it is the same concept as modularity in technology. For example, if you have a big country to manage, let's take China as an example. How you can manage such a big country? You take your country and you divide it into provinces. But at the same time, sometimes it's big in China, in such big a country like China. Managing provinces is still not an easy thing to do. So you have to take also your provinces and you break them into small into cities, not small cities, because there are many big cities in China. And it's not enough because cities are big. You take your city and you divide it into district and so on. So, for example, if you have to take an ID, to obtain an ID, you don't have to go to the central government in the capital, Beijing, for example, or to go to your province capital. You can go to your district and obtain your ID. In this case, you can't or you don't overload the central government or you don't overload the province government. So the small problems, for example, can be solved in districts. And if the bigger the problem, you can go to the city, the local government of the city, and so on. So when you integrate all of these modules, in this example, districts, cities, provinces, you are solving the big problem, which is in this case managing a country. In the same applies in hardware and the software design. As we said, if you have this mobile phone and you want to design a modular mobile phone, in your company, the set of skills that are needed to, for example, to design a Wi-Fi chip is different from the skills that you need, for example, in designing a CPU or antenna or storage or Bluetooth or some gyroscope sensor and so on. So you can divide your big problem, which is designing a mobile phone, and assign every task to a department or a team. And then the collection of these modules, when they are integrated together, this integration gives us the mobile phone, the whole system that work in harmony with each other. In software design, let's say we want to design a student management software. It is not a small software to design a student management software for a university. You will have many modules, attendance, for example, attendance module, students fee management, examination, ID card certificate generation, and so on. There are a lot of modules. So for example, let's say we don't have this design, a modular design, and after a few years, after you design you made your software, you needed to change the name of the database. In this case, if you have a modular design, if you need to change the name of the database, if you have a modular design, you will not change the whole code, because the whole every module of these modules, actually every one of them uses the database. Because to use the attendance management, you have the database. You have to have a database to store the attendance information. Student fees management, you have to have a database that store this information, and so on. So in a modular design, you will have one module that interface with the database. So if you want to change the name of the database, you will go to your interface module and you will change your connection information from that module. You don't need to care about every module. In networking, in computer network, I'm sure maybe you have heard about OCI model, or the Open System Interconnection model. The network module, this OCI module, is divided into layers. So we can call every layer a module. We have modules here, and each module, in this case each layer, has its own specific job. For example, the network layer, its job mainly in routing. It doesn't care about signals. The lower layers will care about signals. For example, if you have a chatting application, your chat application doesn't care about signals or how these signals are going to be modulated at all, or coded or decoded. This module design, for example, if you want in the future to upgrade a part of, let's say we want to modify the network layer or the data link layer, we don't need to change the whole OCI model. We will go to this specific layer and upgrade it or modify it, and so on. So you don't have to change the whole system if you have a modular design. Now let's speak about abstraction. In Latin, abstraction means to detach or to tear off. So abstraction, it defines a small pieces or modules. It defines these pieces boundaries so that they can work together. But at the same time, we make no assumption. Each module should make no assumptions about the other modules. What does this mean? For example, the CPU should not make any assumption about the battery, should not make any assumption about the Wi-Fi module, and so on. I love this conceptual image about modularity and abstraction, how to differentiate between them. So these two techniques, modularity and abstraction, they work together. In the leftmost one here, we have no modularity and no abstraction. We have, let's say this is this space is this is our problem space. This is a problem, a concept of a problem that we want to divide and solve. So in the second one here, we have modularity with abstraction. Why? Modularity because we have divided our space, our problem space, the problem that we want to manage, into modules. And you can see also there are well-defined borders between those modules. If we go to this example here, the most right one, we have modularity without abstraction. You can see why, because we have modularity because we have divided our space into modules. But at the same time, there are no well-defined borders between these modules. You can see how we have small islands, this one and this one and this one. They are contained in other modules, which means we don't have well-defined boundaries between our modules. So what's the ultimate goal now of these two techniques, if you think about it? I mean, we have given example in software engineering, in also hardware engineering, in management. But what is the ultimate goal of these techniques, two techniques? It is managing complexity. So you can apply them in computer science, in engineering, in management, and you can apply them in many aspects of your life.